Hyperloop run. Well done, guys.
Thank you very much. You need to go through the alternate.
Yeah, exactly.
Wow. Bring it down, nicht um.
Good job, guys. Well done. Well done, guys. Well done. Good recovery.
5,
We are ready.
4, 3, 2, 1.
So we did about 40 kilometers an hour without pusher. And it goes and goes. Right after is coming a speech from Elon Musk in approximately 5 to 10 minutes, I guess.
Definitely heard it. Congratulations to the Swiss team completing a successful Hyperloop run. Well done, guys.
Very good. Elon's going to take a short break and he'll be right back. War is also coming up next, so stay tuned.
Well, let's go back to our team and have a look. Ich gehe rüber.
Ja?
Ja?
Kannst du mir einen Gefallen tun? Wer geht denn jetzt rein, um den Pod zu holen?
Keine Ahnung. Hallo, Switzerland.
Hey! Und zwar, ihr seid genau da angehalten, wo es optisch so aussah, wie wenn die Rail die Kurve macht. Genau davor. Könnt ihr mal schauen, was da ist? Ob da
Ich sag's denen, ja. Auf jeden Fall. Hi, Lepka.
Geschwindigkeit was gesehen?
40. 40, 41. Here's our team.
Yes.
Hi, well done, guys. Say hello to Switzerland.
Nice one.
40 kilometers an hour. There's Carl with the control board.
Well, I don't know. Actually, it was a bit of a fail, but I guess we made a run.
Hi, Carl. Say hello
Hi.
to Switzerland. Are you happy?
Yeah, I'm pretty happy.
Finally.
It would have been great to get, the shell on and have lower vacuum. Yeah, okay, we made it. We did it.
Next year.
Next year. Yeah. We launched the rockets inside a tube, and we did that for the first time ever. Nobody's done this. And yeah, I think that's pretty great.
Well done. He's the guy who looks at we always have some water and food and yeah, look with the Swiss flag. Yeah.
Went over there so I can plug in. Stick like that. Tell us if they're missing a ball.
So those guys now bring the pod out of the tube. So the next team is the TU Munich with their war team. They've got like an electric engine. Yeah, let's have a later on a look how they are doing. And I think for the moment that's it. We might be back online soon for the speak of Elon Musk.
So now we're trying to lift the pod onto the platform. We need to hit our center of gravity there because the pod doesn't have it in the exact center. So the weight is about 60-40 and we got to hit it so it doesn't tilt. We have an expert driver here, so he's been incredible this whole week. Thank you, SpaceX, for him. Here on the right side, you can see the pusher. So this is the SpaceX pusher that sadly we're not allowed to use. If we would have been here for the second time, we'd probably have made it, but we can't use it now. There's some issues with their brakes, with our brakes. So we'll be relying only on our propulsion and we won't be using the SpaceX pusher. We'll see what kind of speeds we reach. The team before us weighed 1 ton and was able to reach 100 kilometers with the pusher, so it's pretty strong. Let's see what happens. The forklift is lifting. Octa is looking at all the bands are straight. Now it's off the wooden platform, but it's not perfectly in center of gravity, so it's pending a bit on the left. Wooden wheel is out. You can see Octai and Kai that want to take over up there.
Thank you.
So now we're going up and we're moving on to the platform, which will get us into the tube. This is the first step.
Okay, coming forward.
And the guy with the cap here is Ilias. He's our director, and he's shooting a movie with that script. We have a script with over 80 points that we need to check off before we start. Every single procedure is planned to minimize risks.
and down, nice and easy.
Sure.
Touchdown.
Right. Good.
So you can see how smooth our bearings are, just without propulsing, without anything. The pod just moved backwards. In those wheels, we have bearings that can move at up to 48,000 rounds per minute. And those RPM are very, very hard to get, especially in vacuum. So now we'll have to back up.
Be coming right towards your whole team here as I come out. If you can clear them, please.
So from here you can see the SpaceX pusher very well. It looks like a modified Tesla chassis that runs on batteries just as Tesla does and brakes pneumatically, so with air. Here you can see the control center. This is where the competition is set up, where the data is measured also by our crew, and I'll just join the electrical crew quickly and see what happens.
Take this Allen wrench just in case. That should be for the pusher plate.
Here on the right is the compressed nitrogen that we'll use. We'll pump our tank up to 150 bar, which is 3 times what we ran yesterday. And together with the vacuum, that's probably going to provide quite a nice push. Here you can see Lauren and Carl. Those are our informatics and electrical guys.
What about like your aerosol and stuff you did after the map? What is next step is to like cover the tank? I mean, instead of getting cut all I don't know. I don't want to go off procedure. Somebody going. You're not on batteries right now, right? Can you just check the switches off? Well, yeah, they're pushing it out through the range. Yeah, they're just getting to the other end.
Pocket bike?
Huh?
Are you on that pocket bike?
I am not on the e-bike.
Okay. See that SpaceX pocket bike? We've got a big tower hatch. Incredible media coverage. Very nice. So here you can see protection for our ears. As we said before, this is going to get pretty loud. It's 140 decibel, which is louder than when an airplane starts. Luckily we'll have the tube closed and we'll have no air in the tube, so the sound won't travel that well. Hopefully it's not going to be too loud, but we have ear protection for everyone on team. You can see Jonathan now that's taking care of our Fox dampers. Thank you, Gary, for that if you're watching. We probably have one of the best chassis in this competition. It runs extremely smoothly. You'll see on the GoPros afterwards. And we're just pumping them up so that they have the right operating pressure. We are currently waiting for Paradigm to come out the other end. So the team is at the far bottom of the tube, and we're waiting for them to come out because they have a NAP. A NAP is a network access panel, which is the connection that we need to communicate with the tube. Fun fact, there's Wi-Fi in the tube, so we communicate through the tube when there's Wi-Fi in there, and that we need a nap for. And we're waiting for the nap to come from down in the tube. I think they ran about 1 kilometer, so we need that nap before we start. You can see our stabilization system in there, those 2 wheels. Those 2 wheels will clamp onto the I-beam. So there was a question beforehand what this I-beam does. This piece of aluminium in the middle gives us alignment, so we know that we're running straight along the tube, and we have a stabilization system there to make sure that the pod doesn't shift in the length direction. Then we use the same wheels to travel, and you can see those there. That again, of course, I talked about the RPMs before, very high tech, and the polyurethane, which is on the aluminium, is extremely strong and tested on roller coasters as well. So those are the same wheels. The yellow cable we can see there is actually the cable that's going to be connected to the nap, and we're still waiting for that from the other team.
If you get power, just pump 1 time and
Aber das ist, glaube ich, nur die verschiedenen Einstellungen, oder? Und dann, wenn es zusammengeht,
Sie haben gesagt, sie haben alles gerade gebogen. Echt? Sie hätte sich vorhin verbogen, ja.
Adam Miller and Steve Davis. So Steve Davis is the director at SpaceX, head of special projects, and he's the head of this competition. He organizes all of this, and he's very, very close to Elon Musk. So it's a pleasure for us to have him here. Great guy.
Also, like our bearings just move.
Thank you very much for joining us. We'll be back in just a couple of minutes. We're preparing the pod, waiting for the nap, and we'll see you later. We're filling it up now, so we're getting closer to the run. We have a bit of a delay because of that nap issue and the issue of getting the other team out, so we're getting started soon. You can see the nitrogen being filled in by Adam there from SpaceX. You have our team controlling the pressure. We'll go see that just in a minute. The pod is being pumped up now. So there's not an issue now with your ears, but if we're filming afterwards and you might hear a bit of boom, just turn the sound down.
It looks like we're falling again.
So you can see that we're using walkie-talkies. That's because, well, on the one hand, we don't have enough money for roaming, and on the other, it's a really good communication tool, and we can cover these small distances with the walkie-talkies. Now let's go and see what Carl does. So right here you can see the two main people from SpaceX that helped us out, Flo and Adam. They are longtime SpaceX employees and checked out that the safety of our system was good. So they gave us the final okay together with Steve Davis. We can see Carl, Lauren, and Kai here preparing the pod. Kai and Chris are going to be the two people that are going to go inside the tube afterwards when it's fully pumped up. And I think we can see the pressure on the pressure gauge with Carl, and we'll check that out now. Carl, what are we seeing?
Here we're seeing the pressure of the tank going up slowly. 7 to 8 bars. Yeah, we can see it go up. The tank's warming up slightly, but it's okay. How much? Approaching 80 bars. Everything else looks nominal.
So you can see we're in safe idle mode now. Everything's secured, and we're pumping the pressure up. We're at about 80 bars now, so over half of the pressure. But of course, as the pressure goes higher, it takes a bit longer. It definitely won't take us 2 hours as it did with our testing, because then we did it really slowly. I guess about 50 more minutes, and then we'll be set with that and start the procedure. Adam, can you give us an estimate on the time for our viewers in Switzerland and shout out?
I don't know, maybe 10 or 15.
Cool, thank you. So as we're 20 people, not all of us can work on the pod, and we really decided just those 5-6 people there. They have the procedure list, and they're going to take care of all the steps. When we have a count. So the crowd's back up again. They left, and we have a little. We're a bit late, so we'll see them later now, but you can see the tube running down Northrop Street. This is right next to the SpaceX facility. And on the other side of the tube, we have the vacuum pumps that pump out all the air. So this is the tube they built just for this competition, and it's the second biggest vacuum chamber in the world after CERN. So, as you know, CERN is in Geneva, and it's underground, a 25-kilometer radius of a vacuum chamber, and this is the second biggest after that one. Now let's check out some hats. So during our week here at SpaceX, we had toilets and food trucks. That's about all we had. You can see those food trucks here, and we were able to get some food there. But mostly we didn't really eat. We just drank a lot because of the sun. It's about 30 degrees out here now, and we're all very thirsty and sweaty. Yeah, we're about 90 bar.
90 bar?
So yeah.
Yeah, let's do that.
Some more. We've got a live stream, so I think we're the only team with a live stream.
Oh, that's badass.
And yeah, shout out to all the Swiss people.
Yeah, what's going on? I was one of SpaceX advisors for Swissloop, and these guys have put in an awesome effort this week, so stoked to see them be one of the top 3 teams to be running today.
Awesome.
Good shit.
All right, see you later.
Keep going.
So this is our competition, team from Paradigm. Just cooling off a bit, eating something. How'd it go for you guys?
Very well.
Yeah. Sorry, just our live stream, we're kind of the only one, so trying to take care of it. All good? You happy?
Yeah.
Awesome. All right, enjoy. See you tonight. Bye-bye. So as you can see, there can be a lot of people here because it's 1.25 kilometers long. So we have the food trucks and the memorabilia and just a lot of buzz. Right here, this is live. You can see Paradigm pushing their tube back. So they got at the end of the tube, they got their pod out now, and they're pushing it back. So we might just wait here, get out of the way, and see what their pod looks like. So you can see their pod here. It's about 1 ton heavy, so 4 times as heavy as the Swissloop pod. You can see their shell on top and the air bearings that they use. Well done, guys. Thank you. Woo! Whoa. So that's one of the heavier and one of the bigger pods that competed. We're kind of in between, and TU Munich is only 2.5 meters long, and you can almost lift it by hand. Of course, Elon Musk is not only founder of SpaceX, but of PayPal and Tesla as well. So Tesla's always in the business, and you can see an exposition right here. I believe it's the Model. Oh my God, it's the Model 3. I've never. This is you don't get this car in Switzerland. So this is the Model 3. It's the least expensive Tesla they made until now, and it's all touchscreen and electric. Check this out. Wow.
Yeah. The camera right here. There's one in the side.
Where's
side
the
marker.
open the door?
I feel like I just have to.
Wow. So zero emissions electrical Tesla car. This is the one that's going to bring it to the masses. I think about 35 grand in Switzerland. Base edition, but maybe you can tell us more, Jim.
Oh.
No? You're from Tesla or SpaceX?
No, I'm from SpaceX.
SpaceX?
But yeah, I could probably tell you about as much as you can.
You've got the Tesla Design Center on here as well, right? No?
Oh yeah, Tesla Design Studio's right over there.
Design studio? So design like industrial design or systems design?
Mostly
know?
industrial level design.
Industrial?
Yeah, title design. I think most of the systems engineering is done up in Northern California.
Okay.
National factory.
Are you selling some swag here around, or?
I don't sell anything. I'm an advisor
No,
on one of the teams.
no, I mean SpaceX. Are you selling swag?
SpaceX in general, yeah. There's a swag booth right over there.
Thank you.
Sweet.
You can see the Model X here. That's a 7-seater. That's actually a 6-seater. The off-road edition. And this you get in Switzerland, but that one's the first look, so wow. Maybe we can catch a glimpse of Elaine.
I'm going to come back here, but that's just Are you heading that way? You want to...
Hey,
Well, yeah.
live stream from Switzerland. So, hey Lillian, this is Lillian. Can you...
Hi.
She works at SpaceX as well and was so helpful in the process. And she's going to check our pod out, hopefully, if we're
Yeah.
right.
Hi.
So this is the swag booth. We'll get some of this memorabilia, like hats and stuff. If you want anything, let us know on Facebook. Comment. We'll show you a bit of what there is, and then we'll bring it back for you. So we'll get you our account number, and we'll get you some of the SpaceX stuff. Check it out.
Merchandising manager. The other lady right here was a coordinator. Yeah, we all work in marketing.
There you can see an exposition from SpaceX itself. So SpaceX has, you can't see it from here, but they have their first Falcon 9, the first ever aircraft that went out of space and came back safely. They have it right down the road. And this right here is a small version of it with the Dragon on top, and you can check it out here. Hey guys. Hey, how you doing?
How's it going?
Very good, and you?
Just
Cool. Luca. Nice to meet you. So we're actually pumping up our prototype for the next test run, and we're having a small live stream here in Switzerland. So maybe you can tell us about the Falcon 9.
Okay, yeah, absolutely. So this is our Falcon 9 rocket. This is about a 1/100 scale of the actual rocket itself. At the bottom, you'll see our Merlin, what you're looking at over here on the right. That's held together and integrated into an octaweb, which is a large aluminum structure octaweb. It comes up, and then this is our first stage. Our landing legs, which are made out of graphite carbon fiber, come up. This is our grid fins. This is what steers the rocket as it descends back and goes into our landing. This is our engine, or inner stage. So another composite assembly. Our second stage, our payload fairing.
So other than the payload fare, everything comes back. Is that correct?
That's correct.
Okay, wow. And that's a big innovation, right?
Yeah, absolutely. Reusability. We want it to be just like planes, right? Landing.
So that very small part down there, in real life size, it's this thing back here?
Yes.
Wow.
Yeah.
Cool.
Do you like it?
Check out that one, yeah.
They found 3 that were subparts. They took it across the street and had a machine shop welded up for them. And today they're ready to go.
You have silver woven part, second pipe.
Here?
And up behind it.
There.
Yes.
So this is the Merlin engine. It's one of a dozen? I don't know. How many are there on Falcon 9, you know?
Well, there's 9 on the first stage.
9?
1 on the second stage.
Okay. Wow. All right, so you've seen the infrastructure now. I think we'll cut it here and go back to where we're pumping up. And when we're at 150 bar and getting the process on, we'll be live again for the countdown. See you later. We had an issue that the other team was quite far back in the tube, so the NAP wasn't there. The NAP is the network access panel that we need here to communicate with the tube. But now we've got it, it's mounted, and now we're starting procedures. So the next points, you see our protocol there with the over 80 points that we need to check off. And as soon as we've done that, we'll start with one of the most dangerous parts here, where we'll fill the tank up to 150 bar with nitrogen. And that needs a lot of time, so maybe we'll be off again for a minute or two, and then you'll join us for the run.
Go inside. You have the third light is red.
And we had the NAP coming for the other team, so our battery depleted and it went down in voltage. And once we had the run button pushed, we were not actually able to get connection, so we lost connectivity. And we still have 2 other batteries, so we'll have to replace those batteries. We have 10 minutes for that, and after that time slot, we'll try again. However, we don't have time to pump the tube down to the pressure we want it, so we won't be able to go very fast. But hopefully we'll prove the system safe, and we'll do that in about 15 minutes. See you later.
That looks awesome. Yeah, but like raising it to where the wide point of the car is matches the wide point. Or more or less. It just looks like it's a comment drive.
They're going to pump down. We're at 500 millibars right now, and they're checking how much they can go down. Let's hope the best.
So the Swiss team just lost connectivity to their vehicle, so we're repressing the vacuum tube and going to give them a chance to, I think, fix their connectivity issues. And in the meantime, the German team from Moore is going to be next as soon as we are repressed and can exit their pod. And then if they can get their pod back to life in time, like within a reasonable period of time after the German team goes, then we'll give them another shot. And that will conclude the competition, except for a special event right afterwards. So please be patient while we depressurize this thing, and then we'll pressurize it and then depressurize it. So it'll probably be, I don't know, like half an hour or so. All right, thanks.
Our idea at Swissloop is to build a prototype for a high-speed transportation system. The so-called Hyperloop uses levitating pods to transport passengers in near vacuum tubes at high speeds. We're designing and building a prototype and plan to race it at SpaceX's global Hyperloop competition. The Hyperloop's unique benefits can be summed up into 3 categories. First, there is speed. The Hyperloop allows for a trip from Zurich to Berlin in only 40 minutes, reducing today's travel time by 50%. Second, there is cost. Competitive pricing will be realistic due to the Hyperloop's energy efficiency. And last, the environment. Solar panels placed on the exterior of the tube generate enough energy for an independent and CO2 neutral system. In addition to the realization of our prototype, we aim to create Hyperloop specific know-how for future applications. We're happy to share our vision with you, and we hope to welcome you aboard Swissloop soon. We are Swissloop, and we're developing the future of transportation right here in Switzerland. Our team consists of more than 40 mechanical and electrical engineers, material and computer scientists, as well as physicists. We're based at ETH Zurich and complemented by design and business students from various other Swiss universities.
Key technology is its magnetic hovering or levitation. For this, we're using 4 passive Halbach arrays located at the front and back of the pod on both skis. A Halbach array is sort of a configuration of rare earth magnets brought together in a certain configuration so that you sort of concentrate the magnetic field down towards the track. You can also see we have sort of wheels on our skis. So although there's magnets in there, they really don't actually start levitating the pod until about 30 to 40 kilometers an hour. So until that time, we're riding on wheels. But I mentioned that field which is concentrated below the skis. Once we get up to this speed, we actually start levitating and raise off of the skis and are kind of flying inside the tube. And we can go a lot faster. Again, these are passive arrays, so we're kind of sticking true to this clean, zero emissions Hyperloop concept. The magnets are already magnetized, we don't put any energy into the system, and thus we have no emissions out. So we're still using this technology to go faster at zero emissions. The last is our propulsion mechanism. Luca doesn't really like me to say this, but it kind of looks like a rocket. It's pretty cool, we kind of built like a small rocket. So the system that we're using is a compressed air propulsion system, which is pressurized to 150 bar to kind of give some information or perception to what 150 bar is. Basically here on Earth now we're at 1 atmospheric pressure, 1 bar. If we go into the ocean and we swim down 1,500 meters, the pressure we would feel on us would be 150 bar. So we're basically pumping into this tank 150 bar of pressure. And we release that and we start to fly. Again, this is a zero emissions system, so still sticking true to this concept we had in mind. Just to go briefly in depth into the system, the key component, as you can see, is this carbon composite overwrapped aluminum tank, which is again filled with 150 bar, 100 liter of compressed air. At the specific time during the run, we plan to release this pressure through a control signal from our avionics. Once that happens, a high pressure ball valve is opened any air is released and travels through a system of piping and fittings, and is expelled through specially designed nozzles. When this happens, we generate thrust and we start to fly down the track. When we do this, we estimate we can reach speeds of 400 kilometers an hour. This is great, but when we were designing the system, safety was sort of our main aspect, and we wanted to make a really fast, really creative propulsion system, but it had to be safe. So we designed the whole thing with safety in mind, and designed fail-safes wherever we could, overpressure valves, mechanical relief switches, really intense software to prevent any hazards from electrically actuating it when not wanted. And we're still able to do this, and we're able to still keep this really fast speeds available with the system. And Luca kind of mentioned before, he wanted to get to Geneva really fast. So we're only now at about 400 kilometers an hour, but we aim, or we estimate in the future, to get to this 1,200 kilometers an hour that Luca mentioned, which would then take the trip to Geneva down to 30 minutes. This is our envision, this is our plan for the Hyperloop competition. With that, I'll hand it back over to Luca, and he can sort of wrap things up.
Machine, hè? Dat is een machine. Vast 4.
Nog niet. Dit is het.
This is our booth. We made it. We're one of the 3 teams, and it's incredible. You can see we have a screen here. We have some of our great Swiss memorabilia that we brought. Our shell here exhibited. Thank you to all of our sponsors. Thank you so much. It's been a great journey, and we're happy to be here. See our pod here with our CTO, Chris Imperial. Hey, Chris.
Hey, how's it going? Welcome. See our pod.
Was wiegt 42 Kilo. Ja, Enkelfertigkeit, das ist Tonne. Aber danach doch.
Thank all our great sponsors. As you can see, they're all placed very nicely in our shelf. And again, guys, we are so happy and so proud that we've got all your support, because without you this would have never been possible. And it's a pity that no one is here actually today, because you could have joined us. But it's very cool that we have the General Consul, Peter Hafner, here with us. So he is the acting General Consul here in Los Angeles, and he's supporting us as well, which is absolutely fantastic. And the cool thing is that tomorrow evening he's gonna invite us to his residence here in Los Angeles, where he organized a nice gathering with some guests, and we'll be able to present this project, Swissloop, to all those invited people. And yeah, maybe you could say something.
Yeah, with pleasure. Well, on behalf of the Consulate General of Switzerland in Los Angeles, I wish the Swissloop team a warm welcome to California. I find the whole Hyperloop competition very inspiring, and I'm so happy that Switzerland is represented, not only amongst the top 25, but amongst the top 3 teams. So we're all very proud of you. And tomorrow is going to be fun. We're going to have Swiss people, we're going to have some American people at the residence. We want to show you and we want to honor you, and then maybe, except for having a good time together, that might give you some interesting contact. So hopefully it works out, and I wish you good luck for today's race. Thank you.
Thank you.
200 miles an hour for a student-built pod is incredible. I think it's only going to go up from there with each successive competition. It wouldn't surprise me at some point if we're able to get even as high as 500 or 600 kilometers an hour, maybe more. Despite this being less than 1.5 kilometers in length. So yeah, as you can see, they're pretty excited. So I'll just give like a brief talk and then hand it over to Steve. But I think what this is really all about is advancing the state of transportation, trying new things that have never been done before that can make an incredible difference to people's lives. Get them to where they're going fast, safely, lower cost, and really opening up the world. And it's exciting. It's inspiring for the future. I mean, the reason I love these things is because it makes me excited to wake up in the morning. And you need these things. You need these things. There's a lot of problems in the world, but if we don't have things that inspire us, what's the point of living? And that's what this is all about. So congratulations. Congratulations to all the teams, and congratulations to award the winner.
Thanks, everyone. We're going to then announce the winners in 5 minutes. 200 miles an hour. That's unbelievable. So this brings us to the end of the second Hyperloop competition. First of all, thanks everyone for coming. Thanks for waiting. We have to get this pumped down faster. We know we'll work on it. But thanks so much. This is a volunteer effort by SpaceX and Boring Company employees. So I just want to make sure to thank the entire team here. This group of about 10 people pretty much made the entire event happen. So amazing job, guys. Woo! All right, so to announce the winners, we have a Fastest Speed Award, which we'll figure out who that goes to shortly. And then in the meantime, we do have 3 Innovation Awards to teams that really, I mean, we'd like to give an Innovation Awards to all teams, but we can only give to 3. And so Flo has the first Innovation Award, and that one goes to the University of Texas Team Guadalupe. For their hop tanks used in their air bearing systems, which is a clever way to do it. So come on down, get a picture. Yeah, hello. All right, great job. Second Innovation Award for their brake inhibit system. There were a lot of different systems. This team definitely had the cleverest and most creative way to inhibit their brakes, and that goes to Hyperpod X. All right, and for the third and final Innovation Award, for their propulsion system, which we hope to see next year in the Hyperloop competition, Badgerloop, the University of Wisconsin. And finally, when we announced the second Hyperloop competition, Elon was very clear. It was based on speed. So congratulations to the fastest team at over 200 miles an hour, the Technical University of Munich, Team War. So that concludes the second Hyperloop competition, and per a chat with Elon actually yesterday, there will be a third competition, so we'll see you next year. Woo!
Well, that concludes our Hyperloop journey. I'm very, very proud of the team, and I'm happy to have you on board. Thank you so much, and we'll have you join next year. Bye-bye.